Welcome to a new test and teardown video. This time it's a Brüel and Kjær sound level meter type 2205. It is really a nice instrument, but I know this one is defect because I got a little bag of transistors and stuff from this instrument, so the previous owner tried to repair it and gave up. So now it's mine to play with, and let's see where we are at. The first big question is how to open this thing. I have been cheating a little bit, and I've been looking in the manual, and there are actually two approaches as far as I can understand. One is this screw, and then I should be able to unscrew this and take apart this part. And the other trick is to unscrew the microphone and then access some screws in here, and then I should be able to take away this part. I have not been able to unscrew the microphone capsule, so I don't know exactly what to do so far. But the first inspection is that I took out this, and then I see some battery acid problems, and then I see this white battery acid stuff here, and look at that, it is also all the way in here. It's even corroded the paint. So I mean, there's definitely a big problem inside this one. So there's no powering up, only we need to figure out how to open this thing. And see, this whole thing is a little bit loose. So what I think is this capsule was screwed way too tight, and then the two screws that hold this whole mechanism here is kind of loose. So that is what is causing this problem. Well, I'll go and get a screwdriver and let's see what's in here then. After a little bit of fighting with this screw, I did actually see a little bit of loose, but I can now see we got two other screws going into the aluminium up here, and most likely also down there, because I can see it a little bit down there, right? So that means I'm not able to do anything here, but look what I did. I was able to unscrew the capsule, and the manual also says you need to be very careful with this, because there's a tiny little pin here, and this one connects to this microphone. So I hope this one works, otherwise it's a big showstopper. So I'll save this a little bit, and then in here I think I just need to take those two screws out, right? And then, yeah, let's play with that. Yeah. See this contact, okay. There's a little piece here. I need to be careful about that piece. Okay, this is completely loose and will fall. And down here is, okay. So this is perfectly fine. Now I just know it is there, and it's gonna get lost, so I'll save that. Fantastic, and we are definitely in. Ooh, it's full of sexy fets and stuff, and also some tantalum capacitors, electrolytic capacitors. Well, it's actually running off one single cell 1.5 volts, so there's a switch mode converter in here that makes a much higher voltage. And I just contacted one of my buddies that happens to have a very, very big library of Brüel and Kjær stuff. So hopefully tomorrow we're going to scan the schematics, and then I should be able to locate the different voltages and start from the voltages. Oh, I really like this detail, by the way. See here? Isn't that cute? So when you change the 3 different, no, 4, 5. Ooh, there's so many different ranges. Wow, wow, wow. That is cute. I love the way that that is made. Ooh, look at that. There is a little wire going in there, right? Around here. Oh, that is just so sexy made. They know what they're doing. And this is so super, super compact. Oh, I gotta clean this up a little bit here. I haven't figured out how to take this away and to get in here to the meter, but why do I need to get into the meter if that is working? All we find is just a normal meter, right? And some mechanics that's doing that. So I think I'll just... Yeah, that's the different filters. But I'm just looking for something that is very obvious, but there is no easy fix for this one. Even the PCBs are thin types. And we got a metal shield here. So if there is a switch mode converter, there's, yes, exactly. You will have a inductor like that, right? Huh, that is just beautiful. Well, we're definitely in, and that is a good start. So reading a little bit in the manual and also looking up the capsule. It says here it's a 4117, and that's super easy to find specifications. And it says this capsule is 4 nanofarad. So that should be fairly easy to measure, right? Because I can just do like this. See, 23. I mean, I'm not adding a lot of... I don't know. I actually think there's a big chance my capsule is the problem. Because it's just way too high. I mean, is it shorted? It's mega ohm, right? So that is perfectly fine. So now I'm a little bit worried if I need to waste time figuring out what is wrong with the amplifier and stuff, if this one is broken. Oh no. I think I may have done something really stupid. Because of this really weird reading with this meter, I just said to myself then, well, maybe I should try another meter. So I just picked a random meter like this one, and that one also got a capacitance measurement, right? But I didn't check for the level. So when I connected this one, it actually does measure 4.7 nanofarad, but it says set like wee, like a speaker. So I'm afraid that I gave it way too many volts. So how many volts is actually coming out of that one in capacitance mode? Okay, only 0.6 volts. But that was clearly enough to make this one say a tone that I could definitely hear. But how is that possible? Yeah, of course the membrane will move when you apply voltage, just like it's moving when you apply air pressure, right? Well, that's a little bit funny. I don't recommend you to do this, by the way. I'm still playing a little bit with the sound meter. I think I got a little bit of a breakthrough. Also, I got very, very good high quality documentation on peel.dk for this Brüel and Kjær instrument, and say really, really nice component placement layout information as well on the two different boards. So there is a bottom board with the power supply and output driver. So what I've done is, if we look at the schematic, this is actually a schematic I found in my box that was printed out, and it is actually full of handwritten measurements. But unfortunately, the quality of the schematic is not super good. But you can find a super high quality schematic on peel.dk. The two boards, they're divided by this line. It is not explained in the schematic what is the top and the bottom. That is a little bit annoying. But anyway, I believe all the bottom parts that is working. That is the switch mode power supply, and then the output, and of course this is also driving the meter. The meter is here, and there's not a lot to say about this the bottom PCB, because I think that one works. But let's look at the top PCB. If we look at the schematic, it contains of two sections, and those two sections, they are actually very much the same. If you look at the input stage, there's a field effect transistor, and then let's look at the entire circuit like this, in this area here, right? Compare this to that part. I mean, it is identical. And all those resistors you see here in this circuit, all those resistors in both of the two circuits, they are made using those two red ceramic thin film specially made components. So that is all the normal transistors, and that will be the two field effect transistors. And that one here is V1, and that has been changed. So somebody else before me figured out that that one is the problem, and this is the next stage field effect transistor. And also, if I look at the documentation, they talk about putting in 80 millivolt RMS via a 4 nanofarad capacitor, and then you can measure what is going on in the system, and that is of course what I'm doing here. And as you see, we don't get any response, and this is, well, almost no response. So I'm turning on and off my 80 millivolts, and it is not really responding to the different ranges as well. So this is me poking around with the different ranges. I don't see a lot of changes in behavior, and this also tells me that I input something to an attenuator. It goes to a first stage amplifier, and then it goes to another attenuator, and then nothing happens whatsoever. So of course it's a good idea to start measuring here. There's also somebody put a little pointer here, so this is a good point to measure. But you see what I don't need? I don't even need to measure anything. What I can do is I can just turn on the light here. Look at the indication and look at my finger. See? Just touching V6 field effect transistor shows me this circuit here is definitely amplifying. Oh, so let's try and do the same with the first stage. This is V1. Ooh, nothing works here. So this is my intelligent measurement system that tells me The problem is in this section, and this section is identical to that one. And here's another fun thing. All the DC measure points the previous debugger already wrote down. I'm of course going to double check this, but I think by just looking at those values, I should probably be able to tell you exactly where is the problem. So I let you pause this picture, let you look at the voltages, and let's see if you can come to the same conclusion. That could be cool. So let's see if I'm right or wrong, but I will definitely go and play now. Been poking around with this for a couple of more hours, and I can show you here is all the right DC voltages of the stage that is indeed working. And then there is a very similar first stage here, and this is not working. And as you can see here, we got no current going this way, and this is why this voltage is super high. And when this voltage is high like that, see, then there's also no current going in this way, and everything is of course not right. We got the right gate voltage, and so the input FET here is not active as it's supposed to be. And this is of course why there's no gain, and there's actually also no input signal at all. So when I look a little bit more on this board here, this is where this input FET is located. This is V1, and this one has been replaced by a previous owner or a previous service technician, and it is not working. And I got a little bag of that FET. So somebody pulled out this FET, and then they bought some other FETs, and they made some nice drawings here about the gate, drain, source, how to mount this and how to mount that. But that one is not working, and it is a little bit of a special FET, and obviously they were not able to get that FET. And here in Denmark we got a funny saying that if you want something done, call Peter. So this is what I did. I called Peter, and look what I got. I got one of the original field effect transistors, brand new, never been used. So I hope that I will be able to put this in and get it up and running. I got a breakthrough in this case. Unfortunately, it is really what I would call a showstopper kind of case. This integrated resistor here got cracked resistors, no, broken resistors. So here's the 100K resistor, the center point to this balanced amplifier. This one is missing from this red integrated resistor pack, and it is actually this resistor here, and it is very important to make this work. So of course when this resistor is missing, as you can see here, there's no bias through this one, and then we don't get anything through. And the fun thing is then when I mount this resistor, we actually see this entire circuit works, and after a few seconds then it stopped working. And that is of course because some of the other resistors, all those resistors here, they are inside this red integrated part. And when one resistor is broken, then of course we got other resistors in here that's also broken, or definitely affected by current voltages and stuff like that. So maybe we got humidity that went in here or some other stuff that is wrong. But that means even with a brand new super duper ultra rare hard to get field effect transistor, I don't have this amplifier up and running. But in the documentation it says this amplifier here is doing 45 dB gain, and that is also what the other one is doing. And then we have attenuators in between. So I had an idea about maybe I could just put in an opamp instead and see if that should work. That could be a little bit interesting mod, since I'm never ever going to replace this anyway. So here we go again. with a little bit of all this crap out by. But this is definitely the problem number one. So this is a thick film, high reliability, high accuracy, temperature compensated, all sorts of fancy smancy good resistor thing. But some of the resistors, they're shorted, and half of the others, they change value during the first 5-10 seconds after power on. And that was definitely why the entire circuit was just drifting all over the place. And as you can see here, yeah, it is of course working perfectly fine without all this crap. And that is because I am now only using half of the amplification, and that means of course only half of the ranges are working. But I will of course fix that by just adding an op-amp, because today you can get op-amps with plenty of gain, ultra high input impedance, and all this fancy smancy stuff that you couldn't when this unit was made. So as you can see now, yeah, we are very happy. And it's super easy because those two sections, there's just 45 dB amplification. Yeah, we got a little bit of a toning system here, but that is actually between the two amplifiers. So I just leave this. It's exactly as it is. What I've done now here is I took the input from the microphone directly to the other amp. But here I got plenty of space to mock up a little op amp, and then it's gonna be fine. So I've just tested a few other capsules, and now they're working as well. And now I can proceed with my little life. I am actually a little bit happy about this unit so far. So I think I can end this video with a little bit of a success story. Yes, of course I added a little op amp, and it is doing exactly the same as all this other funky stuff was doing. I had a little problem with the socket, so I had to solder one of the pins. That's annoying, but I was in a hurry here. So yeah, thank you very much for... Hey, yeah, it's really working. So thank you very much for watching. See you again tomorrow, maybe. Bye. Yes, it works. So now I'm done. One final assembly. Everything is completely assembled. Yeah, I'm a little bit sad about the scratches I had to make here in the paint job. I had to remove the battery corrosion kind of stuff here from that paint. But other than that, it is really nice. So here's it's an off. So let's try and crank the knob to battery. Here's battery. And then the next one is fast. And we are now in fast mode. All right. You can also try slow mode, of course. Then it will look much more slowly. Yeah. Fast is better, I think. And of course this is 60, so this way it's better. This way I need to yell a lot louder to make it read something. And if I go to 80, see, then there's almost nothing. Yeah, and the background noise is like 50 something. Ah, it's here. If we're real. Is the fan here? Yeah, it is. I got the scope running here with that fan. The fun thing is that there's a noise cancellation system in my my video here. Will actually remove. Yeah, you see, I have to be very careful. you say? Oh, quiet, quiet. Okay, see you tomorrow, okay? Bye-bye.